Hi, in this video I'm going to give you a quick overview of some of the places where definite integrals may appear in the business world. In the next video we'll put some concrete functions into these examples and we'll see how that plays out. Alright, so where can we find definite integrals in business? Well, just like the most popular place to find derivatives is inside the marginal quantities, the most popular place to find definite integrals is also relating the marginal quantities back to the total quantities. So let's define marginal revenue here as the derivative of total revenue, capital R of X. So if R prime is equal to MR, then the integral from A to B of MR dx is going to be the difference in the total revenue between producing X equals A items and X equals B items. I could have also written right here capital R of B minus capital R of A. But what is capital R of B minus capital R of A? Well, that's exactly what I've written in words. That's the difference in the amount of total revenue that we will receive if we decide to up our production from producing A to producing B number of items. Alright, so anytime we integrate a rate of change, we're going to get a difference in total quantities when that integral is a definite integral. So another rate that we've seen before is the description of production rates. If we have some workers in a factory, maybe we have a function P of T describing the rate at which items are produced depending on the time T. Usually that time is measured as the time since you started your shift. So then the integral from A to B of that production rate P of T is going to be the total number of items produced between time T equals A and time T equals B. I could have also said that if P of T is the derivative of some capital P of T, then this would be equal to capital P of B minus capital P of A by the fundamental theorem of calculus. Alright, on this side we're going to see something new that you might not have seen before. That's what's called a continuous income stream. Now let's say that we've tried to model the rate of flow in some total quantity, let's say our total profit or our total revenue. We've given that in terms of the rate and we're assuming that time is continuous. That's why it's called a continuous income stream. Now, since this f of t is going to be the rate of flow, it's already implied that this f of t is the derivative of the total quantity. The only difference between this and what we have over here is that usually when we talk about the marginal quantities are when the total quantities are a function of the number of items being produced. But over here, when we speak about the continuous income streams, usually the independent variable is t. So here, this rate is a function of time. Over here, this rate is a function of x, the number of items being produced. Alright, so some businesses, just the rate of change of their total quantity may just change in time. And when you integrate that rate of flow, that's going to be the difference in the corresponding total quantity evaluated at the endpoints. So the integral from A to B of the rate of flow and total profit, let's say f of t is total profit, is going to be the difference in total profit from time t equals A to time t equals B. So if you're ever given the derivative, if you're given a rate of change, and the question says, now how much did I do over this certain time period, they're just asking you to integrate that rate of change where you put the bounds on the integral. Alright, so for example, let's say that I've defined f of t as my continuous income stream in yearly profit, and notice that the units on f of t is going to be a derivative type of unit, so f of t here is in dollars per year. That's kind of a giveaway when you see dollars per year, just like for marginal quantities, it's like dollars per item. When you see that the unit is in a fraction like that, it kind of tells you that this is the derivative of something. And then if they're asking a question to find the total thing, then you have to take the integral of that derivative. And so if I took the integral from 0 to 10 of f of t dt, that would be, if f of t is yearly profit in dollars per year, that would be the total amount of profit that I made over the first 10 years. Or I could also say that's the difference in the amount of profit that I've made after 10 years, subtracting off the amount I've made after 0 years. Alright, so in all of these examples here, we see that we're integrating derivative type quantities, and then when the integral is a definite integral, The answer is the difference between 2 points on the corresponding total quantity.